Hi everybody, this is Mr. Lee. In this video, I'm going to show you how to use the video analysis website that we'll be using in class for different kinds of experiments. It's a very powerful tool and it can analyze any video that you upload to the website and get very good data. So I'm just going to go over how to use the website, important things that you should keep in mind when you are making the video, and we'll just go from there. Okay, so the first thing that you should do is you need to have probably a meter stick. We'll probably use a meter stick so that you can have what we call like a reference for the website. So in this video here, I have a magnetic meter stick that goes from the top to the bottom, and that will be my reference. And also in this video, I'll be walking across the screen just so that you can see different things, or so that we can collect different kinds of data. Alrighty, so without further ado, let's begin. Alright, so now we're in the lab setting and I'm about to conduct a lab. I have my reference meter up on the board. And I'm about to show you a kind of lab that we could possibly do. So one of the things that's important when you are filming your experiment is that you can actually see the object that is in reference. So for this video, I'm going to be walking across the screen, but in my hand I'm going to be holding a bright orange object, and that just makes it very easy for us to collect data. Okay? So it's going to look something like this. All right, and it's as simple as that. Now that you have your video, normally what you would do is you would either email it to yourself or upload it to Google Drive so that you can upload it to the website for further data analysis. Okay, so you've collected all your data and you have your video files, and you either email the videos to yourself or you upload it to Google Drive. One of the things I do recommend is if you do upload your video to Google Drive, make sure you retitle the video so that you can find it easier, or probably create a folder for all of your video files so that it's easier to pull up. Now, you're on this website, noragolfa.com/sigmund. This is going to be the video analysis website that we will use. So the first thing that we're going to do is we are going to drag and drop a video here. To make it easier for myself, I put the file on my desktop. Here we go. All right, and so this is the video that I just recorded of myself going from left to right. Now, the website is really user-friendly. The big thing is that you want to start from the top left corner and you just want to go all the way down. Now, if you ever do get lost, they do have instructions here that definitely help out. So the first thing I want to do is I actually want to calibrate. So I'm going to click calibrate, and it says to create a line. So I'm going to go from my top of that meter stick straight down, right about there. Okay, and this will be 1 meter. Okay, so the reason why you want to do that is it helps the program determine exactly the position of each data point according to whatever units you give it. All right, so now what we want to do is we want to set what we call a time 0. So there's myself going across the screen, but I want to say when the ball is like right here, okay, and that'll depend based off of your lab where you want your time 0 to be. So I want my time 0 to be here, so I'm at this current frame. This is time 0, okay. And I want to set my my positioning. So think about this x0 and y0 as like a graph paper or like a coordinate plane. Okay, so if I make my x-axis 0, that means that you see that green line there. That means if I'm going from the right side of the screen to the left side of the screen, I'm going to be heading into the negative direction. But if I make my x0 all the way over here, what that means is that I'm going from a positive position to I'm approaching 0 essentially. Okay, and you know what? I will put my x0 somewhere in the middle, so that what this shows us is that we're going to go from a positive x position. I'm going to cross that x0 line and I'm going to head into the negative position. Okay, and based on the lab, you usually want to set your initial position 0 to wherever you're starting, but I just want to show you all the options. Okay, so that's my x0. I'm going to set my y0. Same thing, anything above this green line is a positive y-axis, anything below that is a negative y-axis. So let's just make it down here. All right, now here's the data points. Okay, so this part of the lab, it gets a little bit tedious, but it's this part that really helps collect good data. So you see these crosshairs here. You're going to more often center or put this at the center of the object. So I'm going to put this right there in the middle of the ball. Now, it doesn't matter where you put these crosshairs as long as you always click on the same location for every frame. So the first thing I'm going to do, I'm going to click right here. Okay, and notice when I click it, the ball moved a little bit. All right, so I'm going to click it again, and click it again, 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 click it again. All right, click it again, again. All right, so just move it across, move it across, move it across, right? And then I'm just going to keep on doing this until I am at the end of the video. Okay. Now, you see here, I'm doing this for every frame, but I could actually change that so that I'm not doing it frame by frame. And what that means is that instead of advancing one frame at a time, I could make it so that it's advancing every 2 frames at a time. So why don't we cancel those data points, and I'll show you exactly what that would look like. So if I were to advance every, let's make it every 3 frames. Okay, gonna go back, let's get data points. Oops, let's see, cancel. Gotta go back to the beginning. Just so you know, when you do all the cancelization, you do have to recalibrate. I guess you don't have to recalibrate there, but I did it anyways. So that's 1 meters done. Time 0 will be this current frame. X, I'm gonna make it right there. Y, let's make it down there. I'm gonna get my data points. All right, so every data point is gonna skip it to 3 frames. Okay, and notice I'm doing a lot less clicking. Okay, you'll get less data points this way, but as long as you have a fair amount of data points, this should be fine. All right, I'm gonna do 1 more over there. Okay, cool. All right, and then all I have to do there is click done. All right, now on the right side of your screen, you should see a table, and this table shows you all of the data points that you collected. Now by default, it'll always collect it with time as one of the variables, and as meters as, or whatever unit you used as one of the variables when you calibrate it. So I'm going to copy both X and Y. Right now, this is helpful just in case you want to upload your data into like a Google Sheets or like a Google Doc. But the important thing here is I'm going to launch the plot. All right, so when you click launch the plot, this screen will pop up. And let's see here. I'm going to click in my upper left-hand corner, and I'm just going to do Control and paste. So it looks something like this. Alrighty. Now, if you see here, this has your x-axis data and your y-axis data, and it also has this column here. This is a plus or minus. That's like for error analysis, and it's if you remember from the actual graph or the actual chart, this was my y-axis. So I actually don't need this column. So what I'm going to do is I'm going to clear that data, and I'm just going to copy my x versus t, right? So this is my x position versus time. So I'm going to copy paste that, right? My x label will be time. The units are in seconds. My y data table will be position, and the units will be in meters. Okay, and titles, just make it as simple as possible. It'll just be a position versus time graph. Okay, and what'd you know? So this is the graph for me moving horizontally or across the x-axis. So you can see I started on the positive side of the x-axis and I approached the negative side of the x-axis. And this is pretty cool, right? But the important thing for us is finding a line of best fit. So the line of best fit comes across these models right here. So what you can do is you can click on the different models to see, which one looks like a good line of best fit. So if I click here, y equals x, that doesn't really look like it's doing much for us. Getting closer, but not quite. But boom, which look at that. If we have a linear model, that line of best fit really does go through a lot of the points. It shows us a good average. Now the important thing for us here is that it actually gives us the formula that we can use here. And so you see here how it says a is equal to negative 1.27, right? That is the a where it goes y equals ax plus b. And this b is 0.8. I'm just going to round up to 0.84. That will be the b right there, if you can see my cursor. All right. Now the cool thing about this is you can actually, annotate the graph. Okay, so it says position the text with the mouse, then drop it so wherever you want. So now the reason why this is important is because we can add the line of best fit formula here, right? So we can say, okay, this is a linear line of best fit, which is very helpful for us. Okay, boom. And not only that, but we can actually put in the formula for the linear line of best fit. So it's going to be in the y equals ax plus b, and so it'll be position. So position, the variable that we use is actually x for position, and it will be negative 1.27 plus 0.84, and that is our formula. I'm going to click add note, and I'll put it right there. All right, I'm going to click done. So the powerful usage of this tool is that you can create the perfect graph for your lab. Now, let's just go back here because there will be some labs where the y-axis does matter. So for that, I'm just going to click the y versus t, right? And we can create a second sheet. Just going to copy paste that, right? And let's see, yeah, all that's good, all that's good, all that's good. And so here you can see that the square is the y-axis. Okay, so that if you take a look at it, there's not a real good relationship here. So, right, that's not looking good. That's not looking good. It's probably like that, but it has like a waviness to it, and that's just me bobbing up and down. All right. Now, me personally, I don't like more than one line on a graph, but there will be some times where I say only one line per graph, and it just makes it easier for us to analyze. And there will be some times where I can say, yes, you can have more than one line per graph, and that'll just be up to the lab that we do and up to our discussion there. All right, so let's actually clear this data. All right, there we go. Now we can save this graph, and when we do that, you can do graph to clipboard. So if you do graph to clipboard, that means that you could copy and paste it to like a Google Doc if you are submitting like a lab report. All right. Okay. The only other thing I want to show you is this idea here called the tangent finder. Okay. And that tangent finder, we will discuss it when we talk about finding the slope for a non-linear graph. But other than that, this is a very powerful tool that we'll be using throughout the year. And we'll just get practice with it. I'll see you later. Bye-bye.